Welcome, dear students. So, today we are going to see about the network models. Yes, what is a networking model? Actually, the network model they describe the architecture, components, and design which is used to establish the connection between the source and the destination systems. Every model will be having their own architecture, they have their own components and the design. Only if these three components or if these three are going to be used appropriately, then we call the networking model as a perfect model which is used to establish the communication between the source and the destination systems. As far as computer networks are concerned, we have two different models, computer network models. First one is OSI model and the second one is TCP IP model. Now we'll go ahead with the OSI reference model. The OSI stands for Open Systems Interconnection or Interconnect Reference Model. So this was developed and approved by the ISO, that is International Standards Organization. Whatever the protocols or whatever the rules and the regulations that are depicted by the ISO that need to be followed by the OSI reference model. Yes, it is a layered framework over which all the design of computer systems or the network systems allow the communication between the all types of computer systems over here. In the OSI reference model, we have 7 different layers. All these 7 layers are interlinked, though they are separate, but they are related to one another. Okay, the 7 layers. On what basis the 7 layers are going to work, or how these design principles are going to be applied? The first point, if you just observe, a layer should be created where a different level of abstraction is needed. Yes. The second one, each and every layer should have a well-defined function. That is, layer 1 will be doing one function and layer 2's function will be different. So they will be performing their own well-defined functions. And the function of each layer should define and should adapt to the internationally standardized and accepted rules, procedures, and protocols. Each and every layer should have their own boundaries. Why these layer boundaries are considered more important over here is mainly to minimize the data flow or the information flow across or between the interfaces. As I have already told, how many layers you have in your reference model, each layer will be performing their own functionality. So that is what they perform the distinct functions. So here, this is the layered architecture of the OSI reference model. If you just observe over here, you have a host A and the host B. Both the host A and host B, they will be communicating with each other with the help of these 7 layers over here. So host A can send a message, host B can also send a message. So now what happens? The first layer is going to be the physical layer. The second one is going to be the data link layer. The third layer will be the network layer. And the fourth layer is going to be the transport layer. The fifth one is the session layer, and sixth one is presentation. Finally, you have the application layer. If you just observe the dotted lines between these layers, that is at both at the host A and the host B, they are logically interconnected by the protocols at each and every layer. That is application layer, you have an application protocol. Presentation layer, you have the presentation protocol. Session layer, you have a session protocol. And transport layer, you have a transport protocol. If you just observe the first 3 layers, that is physical, data link, and network layer, you can just observe these 3 layers, they form the communication subnet boundary. So what is a communication subnet boundary? Of course, if you just, when the data transmission is going to take place between a physical layer, what happens over here is the message will be transmitted in the form of raw bits, bits of zeros and ones. And in the data link layer, the transmission of the data will be in the form of frames. You call it as data frames. And in the network layer, it is going to use an internet subnet protocol, which wherein the data will be transmitted in the form of network packets. At these 3 layers, they have their own protocol. So the physical layer will be having the physical layer host router protocol. Data link layer will be having its own layer host router protocol. Similarly, the network layer also has its own host router protocol. Now we'll go on to the physical layer. The main task of the physical layer is to transmit the raw bits of zeros and ones over the communication path. So what should be taken care over here is how many volts, like as they are going to be transmitted in the form of electrical signals, how many volts should be assigned to the bit 1 and how many volts should be assigned to bit 0. These should be taken care of. And then how much of time will it take for a bit to complete its transmission? So that is what, how many microseconds will a bit take? And then we have to confirm in such a way that whether the initial connection is established. If it is not established, the communication is not going to take place. Finally, we should also take care in such a way that the pins, the network connector, how many pins the network connector is going to have. So here you can just see the physical layer transmission between a sending cable and a receiving cable and how the bit streams are going to be transmitted. Then comes the data link layer. As we have seen, the main task of the data link layer is to take a raw transmission of data, transform it in a line that appears free of undetected transmission errors to the network layer. So in this case, what happens over here is the sender will be breaking down the data into data frames, transmits the frames sequentially in whichever the order it receives. In the same order it is going to transmit the frames and then processes the acknowledged frames. Issues. What could be the issues? Yes, recognizing the frame boundaries. How a frame boundary has to be created and how it need to be recognized. This is the most high priority issue that need to be taken care of, because we need to introduce some special bit patterns both at the beginning and at the end of the frame. The main idea of including the special bit patterns over here is it will resolve that it will overcome the damaged, lost or duplicate frames. So here you have over the diagram. So here you have the data. You can just see a frame over here. So here the frame, each frame will be having a header node, header information and a trailer information. So then inside you will be having a data. So like this, the frame will be transmitted from the sender end and to the receiver's end. Further issues, of course, it should also keep track of fast transmitter from drowning through a slow receiver. This means flow control. Whether the data that is going to be transmitted, if 10 frames are going to be transmitted from the sender, means the receiver should also have the capability to receive those 10 data. And here the line is going to be, if it is going to be bidirectional, both ways of communication, means the acknowledgement frame should also be taken care of. Then comes the network layer. The data, the main task of network layer over here is data will be transmitted in the form of packets. So how the data is going to be delivered from the source to the destination. So here it is a network layer. The main functionality of the network layer is controlling the operation of the subnet. As I have already showed you in the diagram, the communication subnet is formed from the network layer to the data link layer and the physical layer. So which layer is going to control the network subnet or the communication subnet is the network layer. The issues. So here, when it is going to deal all these things, when it is going to perform all these tasks, there are some issues it will be facing. That is to implement the proper routing mechanism to control the congestions, like avoiding the flow control, fast receiver and fast sender and slow receiver problems. To do accounting. Accounting over here is how this one particular sender, how much time he has been transmitted the data to that particular receiver or to the entire receiver. So here accounting, it is going to create or it is going to keep track of a log for each and every sender and the receiver. And then to allow interconnection of heterogeneous networks. The last one is going to be in whichever the order the data or the packets are sent, in the same order it need to be delivered or received. So here we have the network layer, how the packet creation is going to be done. So here you have the packets, it is going to be transported, and at the receiver's end, it is going to be assembled and sent to the layer above it. Then comes the transport layer. The main task of the transport layer is to accept the data, whatever be the data, to accept it from the session layer, split it up into smaller units and pass them to the network layer. So here the pieces will be arriving correctly at the other end. That should be made ensured, or that should be completely taken care of by the transport layer. The main issues over here is transport connection. How the transport connection is going to be maintained by several network connections. So here in this case, the session layer need to have a higher throughput, and it should be able to multiplex several transport connections either to the same network connection, or if the network connections are expensive, to the different network connections. So here we can just see the transport layer, how it is going to perform. So here the data is going to be broken down into segments. So segmentation is going to be done. Once it is received at the receiver's end, the segments are going to be reassembled and transmitted. Further, the issues. Some more issues added to the transport layer over here are, it should be able to provide different types of services for the session layer and also implement the flow control. So that is the reason, as the transport layer faces a lot of issues and takes care of a lot of tasks, we call this transport layer as a true end-to-end layer. And the user of the transport layer should be very much clear cut and crystal clear in delivering the message. So how it should be delivered? He should be aware of whether the message has been delivered to the destination, regardless of in whatever the network the receiver lies. The next layer we are going to see is about the session layer. This is the fifth layer. So the main task of this layer is to allow the users from various different kinds of machines to mainly establish the sessions between them. So once they establish the communication, once they establish the sessions, then only the data transmission is going to take place. So here the session layer allows only ordinary data transport, and it is also going to provide some enhanced services. So what are all those services? If you just observe, means dialogue control, token management, and synchronization. So let us see one by one. So here you can just see how the data is going to be represented in the session layer. So you have a data and you have a header for it, mainly for identification of the data at that particular layer. Yes. Now we are going to see about the each services of the session layer. Dialogue control. Dialogue control over here, it mainly deals with the how the traffic is going to be handled in both the directions, whether the communication is going to take place in both the directions, or in only in one direction, or if the communication is going to take place at the same time in both the directions, or only in one direction. So all these things need to be taken care by the will be taken care by the dialogue control. Token management. Here the session layer provides tokens that need to be exchanged. So whichever whoever the sender or whoever the host machine who is having the token, who is holding the token, will be able to perform the critical section, or will be able to perform the transmission of data to the uh, other hosts. Synchronization. So this synchronization is going to provide a main service called as checkpoints. Few checkpoints will be inserted into the particular data. So why these checkpoints are going to be added or embedded into this particular data is to mainly eliminate the crashes whenever the transmission is going to take place for a long time. After a crash, only the data transferred after the last checkpoint will need to be repeated. So let us take for example, if 10 data are going to be transmitted from sender to the receiver, let us take 8 data got transmitted, and say when the 9th data is getting transmitted, let us assume a crash has occurred. Now what happens over here is, based on the checkpoint, will have a value of 8 data has already been transmitted. So based on the checkpoint value only, we are going to transmit the next, that is the 9th data, which is going to be transmitted again. So this is the main task is the data synchronization in the session layer. Then comes the presentation layer. This is also known as translation layer, because it is this layer which is going to act as a data translator. So what is the data translator? We can just see it in the main task. Here it is going to take care of the syntax and the semantics. Syntax means the data structure. Semantics, what kind of data or meaning of data that is going to be transmitted. So let us see the functions. It takes care of data translation, data compression, data encryption or decryption, syntax, and semantic management. Syntax, when you just read a programming language, for example, say if it is going to be an if condition or a for loop, you will be following a proper syntax. then only the code will get executed. So in the same way, whenever the data is going to be transmitted or passes through the presentation layer, it is going to take care of the syntax of that particular data and meaning. What is the meaning? That is going to be the semantics of that particular data. So it is going to observe these two. Once this is valid, then only the data is going to be transmitted from the presentation layer. So here we can just see, so here it is going to perform the encryption, compresses the data during the transmission, and then it is going to get translated and it is going to reach at the receiver's end. The best example you can take over here is the WhatsApp. The end-to-end compression. You will be observing the end-to-end compression whenever you just transmit the data. The similar functionality is going to be taken care of by the presentation layer. Yes. Internal coding. So here it is going to handle different internal coding of characters or numbers. Okay. And whatever the data structure that is going to be exchanged, that is going to be defined properly along with some standard encoding techniques. So what is this encoding over here is, you can just observe whenever you open a WhatsApp, you can just observe, like for some of your friends, for some of the contacts which you have already stored, after some time you will be observing the code, the signal code has been changed, the security code for this particular person has been changed. You can just see an automatic message that is being popped up. So it is nothing but the same kind of encoding is going to be taken care of by the presentation layer. The presentation layer manages these abstract data structures and converts according to the representation, and then it is going to transmit to the network standard representation to and back and forth. The application layer. This layer mainly it contains of a variety of protocols. So what are all the main tasks? It mainly takes care of the network communication. It provides the functionality to send and receive the data from the users. And the most important is it is going to act as an interface between the user and the application. So what are all the services that is going to be provided by the application layer if you observe? File transmission. So you're going to transmit some files between your sender and the receivers. Mail services, say sending and receiving mail, and other, even you can also transmit videos, audios. All these things are going to be taken care by the application layer only. So the functions: data representation, network service access, application protocols, and session management. So these are going to be the key functions of the application layer. So here you can just observe the data representation. So first it is going to make a request, and then it is going to respond for the particular request that is going to be taken care of. And then you have the network service. So what kind of network service? Whether it is a file transfer, or whether it is only browsing through internet or sending emails. So all these kinds of services. So this is the network access service. Then comes application protocols. Whenever any data transmission is going to take place, according to the data that is getting transmitted, appropriate protocols will be working. So here during file transmission, it uses an FTP, file transfer protocol. If you are going to surf on the internet, it is going to take care of HTTP or HTTPS, hypertext transfer protocol, or secured. Then whenever you are going to transmit some messages, sending messages, it is going to be taken care by the SMTP protocol, simple mail transfer protocol. And if you're going to work on a secured network, then it is going to be taken care by the telnet protocol, terminal network protocol. So finally, here you also have a session management. So how it is going to be managed? So if it is going to be a third party, the session management will be like backend and the front end will need to be coordinated. They need to establish a session and then communication will be taking place. So the working of the application layer, the client mainly sends a command to the server and the server receives the command allocating a port number to the client. And then the request, that is initiation request, will be sent to the server. Once the request is received at the server's end, he is going to send an acknowledgement to the client. Once the acknowledgement is received to the client, it means that the session management is, that is the connection is successfully established between the client and the server. So these are all the protocols, the overview of the protocols used in the OSI reference model. In the physical layer, you have Ethernet, USB, Bluetooth, and IEEE 802.11. This stands for the wireless networks. Okay, and Ethernet is a wired communication. Data link layer, it is going to have Triple P ATM Ethernet. Triple P is point-to-point protocol. ATM is asynchronous transfer mode. And in network layer, you have IP, Internet Protocol, ARP, Address Resolution Protocol, ICMP, Constant Messaging Protocol, IPsec, Internet Protocol Secured. And in transport layer, you have TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. Session layer, you have NetBIOS and PPTP, point-to-point tunneling protocol. Presentation layer, you have SSL, Secured Sockets Layer Protocol, and TLS, Transmission Layer, Transport Layer Secure Protocol. And then in the application layer, you have HTTP, Hypertext Transfer Protocol, FTP, File Transfer Protocol, DNS, Domain Naming Service, SNMP, Simple Network Messaging Protocol, and Telnet, Terminal Network Protocols. So here, yes, what is going to be the easy way to remember the OSI reference model? Yes, here we have a solution. So if you remember this diagram at each and every level, you can just observe what is the kind of protocol it is used and what are all the functionalities that is going to be done at each and every layer. You will be able to remember the OSI reference model and its layers along with its functionality in a very easy way. I hope you understood this concept of OSI reference model. See you in the next topic. Thank you.